Hello everybody, I am Muhammad Azhar Iqbal Nawalgund, Assistant Professor, Department of Physics, Government First Grade College, Mundargi. This is the sixth section on transient current. In this session, we are going to study the measurement of high resistance by leakage method and the 16th session for the BSc 3rd SEM CVCS college students which are affiliated to the Karnataka University. Learning objectives. Theory. The growth and decay of current in RL circuits. Derive the equation for time constant during the growth and decay of current in RL circuit. Plot the graph of time against the current for growth and decay of current in RL circuit. Theory of charging and discharging of a capacitor through a resistor. Derive the equation for time constant during the charging and discharging of a capacitor through a resistor. Plot the graph of time against charge for charging and discharging of a capacitor through a resistor. Understand how to measure the high resistance of a resistor by leakage method. Problems on RL circuits, problems on RC circuit, and leakage method. Session outcome. After studying this transient session, you understand the theory and derivation of time constant equation for growth and decay of current in RL circuit. Able to plot the graph of time against the current for growth and decay of current in RL circuit. Understand the theory and derivation of time constant equation for charging and discharging of a capacitor through a resistor. Able to plot the graph of time against charge for charging and discharging of a capacitor through a resistor. Understand how to measure the high resistance of a resistor by leakage method. Able to solve the problems on RL circuit. Able to solve the problems on RC circuit, and also measurement of high resistance by leakage method. Prerequisites. Already you studied the meaning of transient current, growth and decay of current in RL circuit, equation of time constant for the growth and decay of current in RL circuit, how to draw the graph for growth and decay of current in RL circuit, growth or charge and decay or discharge of charge in RC circuit, equation of time constant for growth or charge and decay or discharge of charge in RC circuit. Graph for growth of charge and decay or discharge of charge in RC circuit. Measurement of high resistance by leakage method. When a capacitor of capacitance C and initial charge Q0 is allowed to discharge through a resistance R for a time t, the charge remaining on the capacitor is given by Q is equal to Q0 into e raised to minus t divided by CR. Q0 divided by Q is equal to E into e raised to t divided by CR. Log of Q0 to the base Q0 divided by Q to the base E is equal to T divided by CR. Therefore, R is equal to T divided by C log Q0 divided by Q to the base E. Or this equation can also be written as T divided by 2.3026 into C log of Q0 divided by Q to the base 10. If R is high, CR will be high and the rate of discharge of capacitor will be very slow. Thus, if we determine Q0 by Q from experiment, then R can be calculated. Connections are made as shown in figure. C is the capacitor of known capacitance, R is the high resistance to be measured, Bg is the ballistic galvanometer, E is a cell, K1, K2, K3 are tap keys. Keeping K2 and K3 open, the capacitor is charged by depressing the key K1. K1 is then opened and at once K3 is closed. The capacitor discharges through the ballistic galvanometer, in which we record a throw theta naught. The throw theta naught is proportional to Q naught. The capacitor is again charged to the maximum value, keeping K2 and K3 open and closing K1. K1 is then opened and K2 is closed for a known time t. Some of the charge leaks through R. K2 is opened and at once K3 is closed. The charge Q remaining on the capacitor then discharges through the galvanometer. The resulting throw theta is noted. Then Q is proportional to theta. Now Q naught divided by Q is equal to theta divided by T. Therefore, R is equal to T divided by 2.3026 into C log of theta naught divided by theta to the base 10. A series of values of T and theta are obtained. A graph is plotted between T and log of theta naught divided by theta to the base 10, which is a straight line. Its slope gives the mean value of T divided by log of theta naught divided by theta to the base 10. As C is known, the value of R can be calculated. Therefore, R is equal to T divided by 2.303 into C log of theta naught divided by theta to the base 10, or R is equal to 1 divided by 2.303 into C into slope. Nature of graph. When you plot the graph of time against log of theta naught divided by theta to the base 10, you will get a straight line. Now you have to find the slope. By using this slope, you can calculate the high resistance of a resistor. Recap. Using the equation of time constant, decay or discharge of charge in RC circuit, an equation can be derived to find the high resistance of a resistor by using the graph. On the basis of this, there are some multiple choice questions. Question number 1. Equation to find the high resistance. Option A, R is equal to T divided by 2.3026 into C log of theta naught divided by theta to the base 10. Option B, R is equal to minus T divided by 2.3026 into C log of theta naught divided by theta to the base 10. Option C, R is equal to T divided by C into log of theta naught divided by theta. Option D, R is equal to T divided by 2.3026 into C log of theta naught divided by theta to the base E. The correct option is option A, R is equal to T divided by 2.3026 into C log of theta naught divided by theta to the base 10. Question number 2. High resistance are of the order of option A, 0.1 mega ohm, option B, 10 milliohm, option C, 1 kilo ohm, option D, 10 giga ohm. The correct option is option A, 0.1 mega ohm. Question number 3. Resistance and capacitors are connected in option A, parallel, option B, series, option C, series and parallel, option D, none of the above. The correct option is option A, parallel. Question number 4. The nature of graph in measurement of high resistance by leakage method is option A, straight line, option B, parabola, option C, circular, option D, none of the above. The correct option is option A, straight line. Question number 5. To measure a very high resistance, we should use option A, leakage method, option B, Wheatstone bridge, option C, Kelvin's double bridge, option D, none of the above. The correct option is option A, leakage method. Reference: the books which are referred for these sessions are Electricity and Magnetism by R. Murugesan, Electricity and Magnetism by D. N. Vasudev, Fundamentals of Electricity and Magnetism by Vasudev Ghosh, Electricity and Magnetism by B.S. Agrawal, Electricity and Magnetism by Brijlal and Subramaniam, Electricity and Magnetism by Sehgal and Chopra, Electricity and Magnetism by K.K. Tiwari. Thank you.